Access to space has long been limited by cost, complexity, and development timelines. Rocket Factory Augsburg, better known as RFA, was founded with a bold mission to democratize space by dramatically reducing launch costs and enabling frequent, reliable access to low Earth orbit. At the center of that mission is RFA ONE, a medium-lift, three-stage launch vehicle designed to carry up to 1.3 tons of payload. But in an industry where failure is not an option, RFA takes a very deliberate approach to development, one they describe as away from simulation towards testing. Rather than relying solely on simulations, RFA validates its designs through aggressive real-world testing. To support this philosophy, the engineering team built its test infrastructure around NI hardware and software, including LabVIEW, CompactRIO, and CompactDAQ. This platform gives RFA something critical: agility. With a small engineering team, they can modify test setups quickly, changing sensors, adjusting data logging, or altering execution sequences in a matter of hours or days instead of weeks. That flexibility allows testing to keep pace with rapid design changes. RFA's testing spans a wide range of complexity. Some systems are compact and portable, used to qualify individual components. Others are large, permanent installations, such as a turbopump test stand powered by a helicopter engine. Because the same NI-based architecture scales across these environments, engineers can reuse knowledge, tools, and workflows across every stage of development. Testing at RFA is also geographically distributed. At their headquarters in Augsburg, Germany, development and system-level testing are carried out. In Portugal, engineers focus on structural testing, including vibration and strain measurements for the orbital stage and payload fairing. The most demanding operations take place in Sweden, where RFA performs hot fire testing of the staged combustion Helix engine. Here, a distributed CompactRIO system controls both the test facility and the engine itself, coordinating ignition timing and managing the flow of volatile fluids like liquid oxygen and pyrophoric compounds with precise deterministic control. By relying on NI's flexible real-time platform, RFA has dramatically shortened test cycles and accelerated iteration. Designs can be tested, refined, and retested quickly, an advantage that's essential in today's competitive space industry. This approach has already enabled major milestones, including a successful 40-second hot-fire ignition test of the Helix rocket engine, an achievement that brings RFA one step closer to routine, affordable access to space. For Rocket Factory Augsburg, testing isn't just a verification step, it's the engine of innovation. By embracing real-world validation and agile test infrastructure, RFA is redefining how rockets are developed and helping make space more accessible for everyone. This concludes today's video. Thanks for watching. If you're looking for legacy NI parts, calibration services, or more technical resources, head on over to apexwaves.com to get what you need fast. We have thousands of NI parts in stock and ready to ship, including legacy and obsolete modules you won't find anywhere else. And if you found this helpful, don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.